So in this problem, we need to determine the equation of a parabola with the condition that the focus lies at 3, 0 and the equation of the directrix given by 2x plus y minus 1 equals to 0. Let us begin. So what we'll do, we'll begin by first trying to understand the problem graphically. We'll consider a straight line. Let's say this is a straight line which is representing the directrix of the parabola with equation 2x plus y minus 1 equals to 0. Next, what we'll do, we'll consider another line which is perpendicular to this directrix line. Now for the we will consider a point lying on this line. Let's call this point as point F with the coordinates 3, 0. Then by definition, this line will be referred to as the axis of symmetry line. It is the line on which the focus of a parabola lies. So now we have the coordinates of the focus and we have the equation of the directrix. Using this two information, we need to obtain the equation of the parabola. What we'll do, we'll begin by first considering a point lying on the plane. Let's call it the point P having the coordinates h, k. Now to find out the equation of the parabola, we're going to use the condition that if we join point P and point F with the help of a straight line, and then we drop a perpendicular from point P on the directrix, and let's say it meets the directrix at M, then by definition PF will be equals to PM. That's the definition of a parabola. So by definition, we will use the fact that PF equals to PM. So we'll start from this point. Now here, how do we find out the length PF? So that's very simple, because we have the coordinates of the endpoints P and F. We can use the distance formula to obtain the length of PF. So all we have to do is take the square root. Underneath the square root, we take the difference of the x coordinates. So that's h minus 3, square it, and then add it to the difference of the y coordinates. So that's k minus 0 whole square. Now the next task will be to find out the perpendicular length PM. Now there is a standard formula for finding out the perpendicular distance of a point from any straight line. So let's go through that formula. So here we have a point P with the coordinates x1, y1 and a straight line represented by the equation ax plus by plus c equals to 0. PM is going to be the perpendicular distance of the point P from the straight line. Then its distance will be obtained by using the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. Here a and b are going to be the coefficients of x and y of the straight line, and x1, y1 will be the coordinates of point P. So using the same formula, we can easily find out the perpendicular length PM. So here we have to start with the coefficient of x of the straight line. So that's 2. So 2 will get multiplied with the x coordinate of point P, giving us 2h. We add it to the coefficient of y, so that's 1. 1 gets multiplied to the y coordinate of k, so that's simply k. And then we have the constant term added to it, so constant term is -1. Divided by the square root of the sum of the squares of the coefficients of the straight line. That means we have 2 squared plus 1 squared. Okay. Now what we'll do, we'll square both sides to get h minus 3 whole squared added to k squared. So this will be equals to 2h plus k minus 1 whole squared divided by, so we have square root of 2, that's 4, added to 1, so that's 5. So we get square root of 5, squaring it gives us simply 5. Now we'll simplify this. That I'm leaving as an exercise for you to try. After simplification, we will be getting h squared plus 4k squared minus h times k minus 26h plus 2k plus 44 equals to 0. Now we're almost there. All we have to do is finally replace the value of h with x and the value of k with y. And this should give us x squared plus 4y squared minus xy minus 26x plus 2y plus 44 equals to 0. And this is going to be the required equation of the parabola, which has its focus at 3, 0 and the directrix having the equation 2x plus y minus 1 equals to 0.